Okay, so we have a project mini-grid design using induction generator. In this project we use induction motor as generator. As indicated in the figure, we can see the prime mover, a DC motor coupled with an induction motor which runs as a generator, and we use this equipment, this motor generator set, to synchronize. And in this documentary we are going to document about the process of the apparatus required and the process in which we synchronize using our synchronizer. So as seen in the figure, we can see the setup. This yellow machine is a DC motor, and we can see here a three-phase induction motor which we will run as an induction generator. And we can see the generator is in star connected, and we are measuring the line voltages. And this is a three-phase watt meter where we get the indication of the generated voltage. And to use induction motor as generator, we need an excitation capacitor. So for the reactive power we are using this capacitor bank, and in this bank we can see C1, C2 and C3. C2 and 3 are in parallel, and they are supplied to a given winding, and C1 is given to another winding. And as this project is synchronization, we need to synchronize at this instant with the national grid. So we can see the national grid being tapped, and it's been stepped down by this transformer into 6-volt supply, and it is we can see it being displayed in the oscilloscope. So this is the grid, this is the supply grid. And to begin our synchronization process, first we need to on this equipment and generate the voltage. So let's begin. So now the motor has started. The motor has started, and we can see the generated voltage. We can see the generator being run, and we can see the voltage being generated. It's 1 volt, 2, and slowly we can hear the speed of the motor is speeding up. We can see the voltage, and here we reach with 300 voltage, and we are now dropping the excitation. It's a line voltage, and we drop this voltage to 220 volt, and 25, 23, and it's nearly 220 volt. And we can see in the oscilloscope the yellow one is the national grid being dropped, and whereas the blue sinusoidal wave is the generator voltage. So now let's overlap these two waves. Okay, I forgot to mention the generator voltage is being dropped down to 6 volt as well. So we can see the reference voltage as the national grid voltage, and generator voltage in blue, which is running in. Now we can see the two waves. The blue is the generated voltage, step down voltage of the induction motor run as generator, and the yellow wave is the step down voltage of the grid. So we need to synchronize them at the instant when both of them overlap. So at instant like okay, not like such, at instant when both of the waves get overlap, and at such an instant we need to synchronize, and this is the perfect synchronized wave. So we need to find out at which instant are these both the waves being synchronized. So for this we have a small circuit for the indication of synchronization, and this LED which is glowing indicates synchronization, as we cannot see oscilloscope at every instant. So when there is perfect synchronization, this LED is totally off. So likewise we can do synchronization process, and this process is more explained at this by this figure. So we can see the induction motor and generator IMAZ being stepped down, and it's been passed to an automatic synchronization which are yet to build, and another induction motor and generator is stepped down. So this is the block diagram for synchronizing two induction motor run as generator, and we can see NEA grid, Nepal Electricity Authority's grid, being stepped down through this transformer, and which is passed to an automatic synchronization. The induction motor and generator is stepped down and passed to an automatic synchronizer as the layer was there, and we need to automatize it yet. And this automatic synchronizer switches this switch over here, and both the generated voltage can be connected to a single phase, connected together, tied up together. So this was the total experimental setup, preliminary setup for synchronizing an induction motor as generator. We can see the 220 volt being generated, and we can see here when it is totally off, the synchronization process can be done. When the line is the yellow line, when it is totally off, so we can see certain impulses, so neglecting those impulses, we can synchronize it at such an instant. So